Okay, so today we're going to be looking at more of an AP style question. I previewed this before that we had these, and what I called them was table problems, although they don't necessarily have to be a table per se. It could be a graph or giving you a function in part of a table or a function in a graph or two graphs or whatever the case may be. This one specifically for our first example that we're going to look at actually is a table. We're dealing with a couple different functions and a couple function derivatives. And we did this when we talked about our product and our quotient rule. So they define some other function, in this case like h of x or p of x or m of x or n of x or whatever it is, as some combination of the other functions that were given. So I wrote it all down so that you could just pause quickly and write it down yourself before we jump right in. And again, when we did this with product rule and quotient rule, again, the important part to think of is if I'm dealing with these generic functions, it does not mean and does not look any different than if I was doing this in place or with, a function x squared in that. So be careful not to lose all of your rules. Don't just consider that this is like if I took the derivative of this, it would just be derivative and derivative. That's not the case. This is a product, so I need to apply the product rule for it. So don't lose that when you're going through. And that will guaranteed be an answer on an AP test, is just taking the derivatives as they stand rather than actually applying the rules that go with it. So first case is simple. We're just going to apply or just find these values. So the first one that we have is looking at this composite function where we have g of x or f of g of x, excuse me. So our first problem here for h of 2 is finding f of g of 2. So we look at our table, we find g of 2, which is 4. So that really means that we're finding f of 4, and f of 4 is 3. So that should be my answer for part A. Part B asks us to find h prime of 1. So again, I'm looking at a derivative. So let's generically come up with the derivative of this function. This function is not a product, it's not a quotient, because this is not f times g of x, it's f of g of x. That means that this problem actually is a chain rule situation. So if I was finding h prime, I have an outer function and I have an inner function. My outer function here is f. My inner function here is g. So chain rule tells us I have to take the derivative of the outermost function first. Outermost function f's derivative would be f prime, again, of whatever. And that f could be, x squared, it could be x cubed, it could be sine x, it could be whatever it is. That is going to be like our outermost whatever that derivative is. So outermost of the original argument. And then we multiply by the derivative of the inside function, so that would just be g prime. So I'm looking for h prime of 1. So in my table, I'm looking for f prime of g of 1. So g of 1 is 2. F prime of 2 is 6. And then g prime of 1 is negative 3. So I should get negative 18 for my answer. So again, even though this actually is exactly what we wrote last lesson on the chain rule, it's just the generic version of what the chain rule looks like. Part C is asking us about this other function, p of x. So if I was finding p of 2, I would need to find g of 2 and then f of 2 squared, which is 4. So looking at my table, I'm not dealing with any derivatives here. This is like an algebra 1 problem or algebra 2 problem. So g of 2 is 4, f of 4 is 3, so I have 4 times 3, which is 12. Great. Simple. AP test wouldn't ask that question. AP test would ask the next question, though. They'd be asking what's p prime. And again, be careful. Don't lose what your rules are. This is a product, so first and foremost, I have to apply the product rule for it. And you should be thinking, ooh, this is not just a product rule. In fact, I'm dealing with this x squared, so f of something, and so that means that this section is going to be a chain rule. So generically, I'm going to come up with the derivative of what p prime would be. So I'd have to use the product rule, so I have to take the derivative of the first function, which is g prime, times the second function, f of x squared, plus my first function, times the derivative of my second function, and my second function deals with this chain rule, so I'd have to have the outside function and the inside function separately. The derivative of the outside function would be f prime of x squared, and then the inside function's derivative, if I take the derivative of x squared, I get 2x. I ran out of room. What I'm looking for is p prime of 2. So I'm actually going to let you do this one. So pause it, come up with your answer of when you actually evaluate it 2, and end up using your table. What you should get, if you did that problem, you should get negative 32. So hopefully we're all on the same page there. So again, that's one way that you could see these table problems, and you could see chain rule or product rule or quotient rule. You could see those things getting tested rather than just find the derivative involving one of those things, is that they have a lot of generic representations of these functions, and so you have to end up using then your rules to get to that place. That was specifically looking at a table, but we could look at or it doesn't necessarily have to be a table. It could be a graph too. So let me write down our next one. So instead of giving you a table of problems, I'm going to give you a couple graphs. All right, and again, we're going to define this new function. H of x is going to be f of g of x. And our question is to find h of 0 and also h prime of 3. Okay, so let's start with the easy one. Let's start with h of 0. So if I was dealing with h of 0, I'd be finding f of g of 0. And I have a graph to do that for me, so I'd be looking at my first kind of inside out, actually. H of 0 looks like it crosses that here at 4, so then I'd be looking at f of 4. And using my other graph, the actual function value at 4 is 3. So my answer here should be 3. Part B again is asking a derivative, so generically, before we actually get to this piece, generically let's find the derivative of h of x. This again is a chain rule, so I'd have to look at the outside function and then the inside function. Derivative of the outside function would be f prime of g of x times the inside function, which is g prime of x. And after I get that derivative, I can find the actual value here at 3. Okay, slightly trickier because, this first one's actually not bad. I'm going to write up my g of 3. If I'm looking at 3 here, it looks like it's at 1, but we can confirm that. And you shouldn't always go on like what it looks like. That's really important. So this one is actually going down 4 over 4, so we do have a slope of -1. meaning that, this value here should end up crossing at 1. So be careful, like you can't just go with what it looks like. If it looks like 1, you have to make sure that you can confirm that you can actually write a function for it and you could get to that place. G prime of 3, we just kind of talked about that. This idea of a derivative, we know in calculus, means that we're dealing with some rate of change, which really means that we're dealing with slope. So because at positive 3, and we're looking at the rate of change at that curve, this is obviously a linear function, but even if it wasn't, we could come up with maybe the derivative if we were given something. We could come up with the slope at that particular point. And we know that the slope at this particular point, because we know rise over run and we have a graph that's given, we know that slope is -1. So G prime of 3 is -1. F prime of 1, if we look at our value here, or our curve here, again, if we're dealing with a prime, we're dealing with slope. So we're looking at the rate of change. So at this rate of change, we're going up 3 over 2. So our slope should be positive 3/2 times that rate of change that we had before of G prime of 3. So altogether, we should get -3/2. So again, we could have a mix and match here. We could be given a table of some values and a graph. We could be given a function and a graph. We could be given a table and a function. We could be given all sorts of mix and match ideas to apply these applications and look a little bit more generically at, say, chain rule or product rule or whatever. The last piece today is talking about inverse functions, and this is arguably the hardest part of today's lesson. So in order to do these inverse functions, there's a couple ways that you can look at it, but I think that it fits really nicely with the chain rule situation and kind of what we were just looking at, with the graphs and the tables and things like that. Inverse functions, if you remember, are functions that undo other functions. So that means that every input value for this original function becomes an output function for the inverse, and every output for the function becomes the input for the inverse. So our x's and our y values flip. So if I had an ordered pair, 1, 2, that was in the original function, in the inverse function it would be 2, 1 would appear. So that's number one. What you have to remember with inverse functions is that the inputs become the outputs become the input. Another way, so like one way to find that is to actually switch x and y in our functions, but another way to find that or verify that it's an inverse is we use this idea of a composite function. So if, say, g of x was some inverse of f of x, that would mean if I do the composite, I should undo all of my pieces and I should end up with just x. Likewise, also f of g of x would also give me just x. And so because we're dealing with like this idea of composite functions and functions in other functions, and we know how to find derivatives of those pieces, I like to group this inverse function idea with chain rule because I know how to find the derivative of a chain rule situation. So for our last example today, we're actually going to use the table that we had above, but we're going to cut out the g of x. We're only going to use the f of x. So for example, 1. So if you have that already on the same page, you don't need to necessarily rewrite it. Just draw an error for yourself or something. Oops, that's -2, not -3, crazy lady. Okay, here we go, -2. So here's my table, and I'm going to ask you some questions. I'm going to ask you to evaluate f of 1. I'm going to ask you to evaluate f prime. Oh, I don't want to do that, actually. We're going to find f inverse of 3. And then the last question is finding f inverse's derivative at 3. So first one's obviously easy. We can just read that from our table. F of 1 is going to be -1. Great. F inverse of 3. So like I said, in inverses, outputs become inputs and inputs become outputs. So instead of, like, we're not actually looking for, obviously this x value of 3. This would mean that we're looking for where the y value is 3 and the x value that would correspond to that. So if we look at our table that we have, our value here, our y value is 3 at 2. So that means that our inverse function here happens at 2. So in other words, the 0.23 appears in our function, the 0.32 would appear in my inverse function, where the x's and the y's switch. Our last problem is actually dealing with finding the inverse's derivative. So what I like to do, because I think that it gets confusing when I'm talking about f inverse prime, there's too many symbols, so I'm going to write out this function, or define a new function, g of x, as the inverse function. And so that means that for question C, I'm actually looking for g prime of 3. And that's a little bit more user-friendly for me to deal with, rather than looking for f inverse prime of 3. I like to talk about it this way because I just think it sounds better and I can actually wrap my head around it a little bit more. And also, because I want to deal with this piece that we just talked about for inverses, I want to use g so that I can see that again a little bit better. Okay, so here's my recommendation when you are dealing with inverses. I like to start with my composite function. I actually like to start with the second one. You can do either. It just, a lot of times this second one that I'm dealing with, like f of whatever my inverse is, that actually helps me find it a little bit better. So I'm going to start there with this rule that I know about inverse functions. And then I know I'm dealing with a derivative, so let's take a derivative. So if I take the derivative of this function, this is a chain rule, so I take the derivative of the outside function, which is f prime of g of x, times the derivative of my second function, which is g prime, or inside function, I should say. And that's why I like to do it in this way, because I'm looking for g prime of 3, and so I have g prime of x. If you did it the other way, you'd end up with g prime of f of x times f prime of x. And so you'd be looking for, like, the g prime would be there, but it'd be g prime of f of x, and so that's just a little bit more complicated. You don't have to do any guesswork. You know what your x value is for this case. X is 3. And we actually haven't done it this way before, but since I took the derivative of this side, in any math problem, what I do to one side, I have to do to the other. So I took the derivative of this side, I have to take the derivative of this side of the equation too. Derivative of x is 1. Okay, so now I'm looking for g prime of 3. Here's g prime of x, so that means my x value here is going to be 3. So I'm looking for f prime of g of 3. And just to isolate this, since I have, this stuff times that, I'm going to divide and move that to the other side. So I'd have 1 over f prime of g of 3. And if it makes it easier on you, this will always be the form for that. So if you do want to just memorize inverses rather than coming up and deriving it every time, go for it. I think that that's harder for me. I like to just derive it every time because it doesn't really take a ton of work anyway. But you'll always end up with this format here at the end. Okay, so first we're going to use our table obviously for f prime, but we need to find out what g of 3 is. Remember, g is the inverse function, so that means that we've already actually answered this question, but since we're looking for g of 3, that really is looking for not the x value of 3, but the y value of 3 in our original function f. So our y value of 3 happens here, our x value then would be 2, so g of 3 would end up being 2. In other words, they're asking you about since g is the inverse, they're saying, what's the x and y switched, what value of x gives this y value. And then I know that f prime of 2, if I look at my table, f prime of 2 is negative 2. So my overall answer should be negative 1/2. Again, this inverse idea is a really common AP question too, and you'll get some practice with it. I have a whole nother worksheet where there's a bunch of different practice problems for inverse functions. So that's in the Drive folder if you want to check that out. If you're not super comfortable either yet or in preparation for your test, that's kind of an important feature that we can kind of get the hang of, and you will get the hang of it. I know it seems like a little bit of a lot right now, where we're dealing with this composite function and then we have to do this crazy stuff for it. But once you get the hang of it, it does seem and will get a little bit easier. So if you're a little bit confused, that's okay. Make sure you ask questions. Make sure that you're doing some maybe extra practice problems where you can kind of get the hang of this inverse function a little bit better.